Today, we'll be solving LeetCode 207, course schedule. This is a classic graph problem where we are asked whether it's possible to finish all courses given their prerequisites. Each course is like a node in a graph, and each prerequisite is a directed edge pointing from one course to another. For example, if we say you must take course 1 before course 0, then there is a directed edge from 1 to 0. The key insight is that if the graph has a cycle, it means there is a circular dependency and you can never finish all courses. But if there are no cycles, then it is possible to finish. So the problem becomes, given a directed graph, check if the graph has a cycle. If there is no cycle, return true, otherwise return false. There are two main ways to solve this: depth-first search or topological sorting using breadth-first search. For this explanation, let's use breadth-first search with topological sorting, which is also known as Kahn's algorithm. Here's the step-by-step plan. First, we count how many prerequisites each course has. This is called the int-degree of the course. Then, we put all the courses with 0 int-degree, meaning no prerequisites, into a queue. Next, while the queue is not empty, we remove a course, count it as completed, and reduce the int-degree of its neighboring courses. If a neighbor's int-degree becomes 0, it means that course is now available to take, so we add it to the queue. At the end, if we have completed all the courses, we return true, otherwise false. Now, let's carefully explain the code line by line. We define a function called canFinish that takes in number courses and prerequisites. The first step is to build the graph. We say graph equals a dictionary where each key is a course and the value is a list of courses that depend on it. At the same time, we create an array int-degree of length number courses, filled with zeros, to track the number of prerequisites for each course. Then, for every pair A, B in prerequisites, we add A to the list of graph at B, because course B leads to course A. We also increase int-degree at A by 1, since it requires one more prerequisite. Next, we initialize a queue with all the courses that have 0 int-degree. These are the courses we can take right away. We also keep a counter called taken, starting at 0, to track how many courses we finish. Now we process the queue. While the queue is not empty, we remove a course from the queue, increase taken by 1, and then look at all its neighbors. For each neighbor, we reduce its int-degree by 1, because we have now completed one of its prerequisites. If int-degree of that neighbor becomes 0, we add it into the queue, since it's now ready to take. After the loop ends, we check if taken equals number courses. If it does, it means we were able to finish every single course, so we return true. Otherwise, there must have been a cycle, so we return false. The time complexity of this solution is O of V plus E, where V is the number of courses and E is the number of prerequisites. This is because we process each course and each edge once. The space complexity is also O of V plus E, since we store the graph and int-degree array. And that's how you solve LeetCode 207, course schedule. Thank you for watching and let's keep learning.